and welcome to the second COVID-19 Robots and Us weekly discussion with experts. We have some incredible experts this week with a strong focus on disaster robotics, social robots, and human-robot interaction, which is only fitting because this week is the 15th annual International Conference on Human-Robot Interaction. And the theme for 2020 was supposed to be real-world human-robot interaction. And yet, ironically, the conference is now taking place online. I'll share some more information about events coming up this week in the Human-Robot Interaction Online conference. But meanwhile, on Saturday, Wired magazine called for us, post-pandemic, to ditch all the technological tools currently aiding us, calling them tech-enabled tools of social distancing. And well, we're seeing some interesting real-world experiences developing through our own online interactions. And this was a topic raised at the end of last week's discussion. So we're going to dig in a little deeper today. You can also see the video from last week's discussion on the Silicon Valley Robotics YouTube channel. But we're going to dig into the topic of, is it social distancing or is it physical distancing? Can we actually have an emotional connection while we're not physically present, while we're only virtually present? And that's something that the experts today can really dig into. But I wanted to start with a roundup of what's happening in the Bay Area with Jessica Armstrong and Rachel McCrafty, if she's able to join us. And last week we talked to Guy Cavalcanti about the open source COVID medical supplies group, and to Alder Riley from Helpful Engineering. And both Jessica and Rachel are involved in those groups and also Project Mask Making and other initiatives like that. So I just wanted to touch base with what's happening in the Bay Area tonight. And the housekeeping for tonight, if you're not a speaker, please keep your video off and your mic on mute. If you've got a question for our experts, please put it in the chat. We'll be monitoring it and doing Q&A after our introductions. But first, over to you, Jessica. Can you tell me a little bit about what's happening in the Bay Area?
Yes, thank you for the introduction, Andra. I believe Guy was here last week speaking as a whole on open source COVID-19 medical supplies, so I don't want to go that much into that, but obviously we have a crisis on our hands with the pandemic as far as the supply chain goes for medical equipment. You know, you see it all the time in the news, especially with New York City. They're running out of ventilators, they're running out of masks, they're running out of face shields, they're running out of all sorts of PPE. And the open source movement is sort of stepping up to fill that gap. Now, obviously, it's best to have, you know, commercial, validated, FDA-approved designs, but, you know, we're getting reports of people cutting up 2-liter soda bottles and using them for face shields, or, you know, whatever they have lying around, trying to jerry-rig ventilators so that one of them will treat 9 patients. And we think, you know, instead of on-the-fly solutions like that, we should at least have something that is somewhat validated, and to have makers be able to step up and fill that gap. So I think we've put out, I think like 17,000, I have to check exactly, medical devices or masks. We've been making a lot of face shields, things like that. And here locally, we have quite a few active groups. I think one of the largest one right now is Maker Nexus. Through their makerspace, they have been making a lot of face shields mostly. And they are actually trying to get to a point where they can get a die cut manufacturing process going to really scale that up. We have a lot of local mask making groups, and I know Rachel had one of them, so I don't know if I want to go too much in case she shows up, but there's also a few others. And getUsPPE.org is I could probably put that link in the chat. That's an important one.
That would be great. And one of the things that we really talked a lot about last week was where the large manufacturers in the US can step in and start producing tens of thousands or hundreds of thousands of things, and where there was still going to be a need for locally sourced, locally produced things, and particularly around non-FDA, non-critical things. The face shields is a great example of something that well, let's say you can do it badly, but it's a lot less, it's a lot harder to muck it up, shall we say. But we're looking at how hubs, local hubs you were talking before, how local hubs like Make a Nexus or Circuit Launch, which I know is also doing face shields, can become a place where larger amounts of materials can get sourced and then distributed to individual makers. And it's that level of organization that's lacking at the moment that you're trying to step in and fill. Is that correct?
Right. I mean, I think when you're talking about industrial manufacturers, any kind of large scale production plant, first of all, we would love you to get involved. You know, obviously we know larger companies like Tesla are out there producing ventilators now, and they're obviously going to dwarf our capacity of what we can put out. So we are trying to fill in the gaps. And I know we were talking earlier about Circuit Launch, you know, maybe having a hub to provide approved materials for makers. And I think one of the missions of OSCMS is to make sure any of the local makers, and you don't really have to be associated with a group, you can be an individual group or an individual with a printer and then make something and get it to us. But what we as OSCMS want to do is make sure the designs that we're putting out are as safe, effective, tested, validated to the best of our ability. You know, obviously we don't have time to go through the old FDA process, but we have engineers and many people who have been through the FDA 510K medical device process.
And you've been doing actual field trials with health medical professionals.
Trials, so I was going to get to next, with medical personnel from hospitals using the equipment, giving us feedback and everything like that. So we definitely want to make sure there's, you know, some kind of like a Captain America sort of hero thing going on, you know, sometimes with individual makers, which is great spirit, like who I approve of the spirit behind that. But we want to make sure that, you know, they're putting out validated designs. So we have a database of those on the OSCMS page. And we're hoping once we start source materials and have more of a hub, which should be in the next few days, I hope, that we will be able to get out approved materials so people aren't making masks from, you know, whatever fabric they got from Joann's, for example. So that has the filtration capacity that is needed in a professional hospital context. So
that's great.
Yeah.
I'm seeing that that's actually a problem with some of the gear that's being sourced from China is a lack of certainty over the certification. So anything that we can do, I think, to validate that something has been checked and is compliant or meets certain standards, then that's really critical.
Yeah, and we really need to just get out the education and the resources to as many people as possible regarding that. And also sort of locally, we need to act as a liaison and be in contact with the local city and state authorities. We'll let them know what they're doing and get everybody involved. But I mean, there's so many ways to get involved. There's makers, but also logistics. We recently, and I'd have to pull up their name, but we got a group. Oh yeah, Dames Don't Care Motorcycle Collective. A group of lady motorcyclists that are willing to get the proper materials and deliver it, or deliver completed PPE to hubs where they can then be sent out to hospitals. And, you know, that's great if you want to volunteer for that, because we do want to be sure we are practicing social, or I know we talked about calling it social distancing, but physical distancing practices as much as possible. And
yes,
especially important, right? It's especially important when you're manufacturing medical equipment.
Clean lab practices and staying safe. And in fact, if we don't get Rachel on the call this week, hopefully next week, because she can say a lot about clean workspace practices. And,
right.
you know, that's an education that we all need to be going through at the moment. So thank you very much, Jessica. I'm going to now, and I didn't really introduce you. Jessica Armstrong's a mechanical engineer at SuitX, and she's the local coordinator for the open source COVID medical supplies group. And Jessica, if you can put those links into chat now, that would be really, really great.
Okay.
Now, what I'd like to do is give a brief introduction to the rest of our panelists, and then I'll ask them each to introduce themselves, because they do so much more than I can probably squeeze in. But we have Robin Murphy, the founder of the field of disaster robotics and the Ratheon Professor at Texas A&M University. We have Ross Mead, the founder of Semio and the VP of AILA, and one of the first people I met when I was getting involved in human-robot interaction. Also Wendy Ju, who's, you know, has written the book, literally speaking, on interaction design, and is now sadly at Cornell Tech. The Bay Area's lost her for the moment. We also have Cory Kidd, who's the founder of Catalia Health, social robotics expert, and can speak about getting your robots out into the real world for medical purposes. And really, Cory's one of the few people that's managed to achieve that for a social robot. In fact, probably the only person. And we also have Ken Goldberg, who's the director of the CITRIS People and Robots group at UC Berkeley, although that's a UC campus, a UC-wide initiative. And I'd like to hand over to Robin first to please say a little bit more about the whole range of initiatives you've been involved in and what you're learning from the disaster robotics field can say to the rest. You know, how have the other disasters that you've worked on compare to the current COVID pandemic, and what can we do in robotics?
Well, thank you very much for having me here. What a great group of people, and I wish we weren't physically distant, because I'd love to meet all and talk with everyone personally. But from a bigger perspective, I have been working in disaster robotics since 1995. And the field of robotics was really established about then. The very first use of robots was at 9/11, ground robots, and we've seen them, multiple disasters worldwide, and now robots, particularly aerial vehicles, are becoming commonplace. So when you think about disasters and what we're learning, one of the things to keep in mind is that disasters are actually considered all hazards. Everything, not just, most people think of it as search and rescue, where you're trying to find a missing person or find somebody in a collapsed building. All hazards means that something bad's happened that exceeds local resources, that there's lots of different government agencies and not NGOs like the American Red Cross, those sorts of things, as well, of course, as citizens. So it's a big event by definition. And of course, the really first really big infectious disease for us to start thinking about as roboticists was the Ebola outbreak in 2014, 2016, that 2-year time period. And that was only an outbreak. It wasn't even an epidemic, not at the level, you know, now we have this COVID as a pandemic. And so during the Ebola outbreak here in the United States, the White House Office of Science, Technology, and Policy, and then later NSF, did a series of workshops, and myself and Ken Goldberg were among those who participated and worked with various public health officials and groups such as Doctors Without Borders. And so I'm gonna nerd out here and give you a little bit. I'm gonna share my screen and show you some of the things we've learned about infectious diseases in general, and for COVID in particular. So as we look through for this, there's really 5 big categories of uses of robots, and everybody immediately thinks of clinical applications, right? The things that are directly related to the healthcare industry. A lot about in the news about using aerial agricultural drones to spray in China and South Korea, you know, doing different substances. We've also seen foggers with their telemedicine, the ability for doctors to interact with patients and other medical professionals, to be able to work remotely, to have nurses be able to take temperatures remotely. Also prescription and meal dispensing, and even patient outreach, being able to help process admissions and also get people to the right location in the hospital without having to expose the personnel to that. And certainly clinical is very, very important. But there are 4 other categories that are very important as well. Logistics, when you think about how are you getting infectious materials from point of injury to point of care or to a laboratory, delivering supplies, how are you getting those N95 masks to the right people, or how are you getting food to people who've now been self-quarantined? So that's an important thing. Public safety is important. And when you think of public safety, think of that as law enforcement and fire rescue and those kind of activities. And so the one big thing that we've been hearing a lot about in the press is the use of aerial vehicles and some ground vehicles to use thermal to indicate, you know, to try to identify those who are infected because they're running higher temperature. Jury's still out on that one, whether that's a good one. It didn't work very well in SARS and MERS, but hopefully we'll get a little better results. Quarantine enforcement. Classic case in Italy where they were using drones. I mean, they're being used in at least 8 other countries for quarantine enforcement, but the Italian mayor is apparently yelling through the loudspeaker on the drone, "What are you people thinking?" Except for he's swearing at them, which is probably a violation of everything we know in human robot interaction to get the positive effects we'd like. Continuity of work in government. That's something we didn't see in Ebola, right? Ebola was an outbreak in a rural part of the world mostly, although, you know, it happened here in Texas, in Dallas. But now it's very much more to think about continuity of work in government with telework. One of the things that we're able to communicate over Zoom, we're using laptops, but we're also not trying to keep the power grid working or wastewater treating plants working and stuff. And that requires physically turning valves. And I think that's something that, you know, is a gap that we've seen in robotics. And then being able to provide any kind of assistance. Public outreach, that's one that surprised everybody. Did you know that in Times Square, there was actually, and in China, robots going around saying, "Hey, take this quiz to see if you have COVID. Remember, wash your hands," do these things by local businesses trying to do that. So we're seeing quite a broad set of robotics. And I think the big important lesson for all of us at this time is to remember it's not just always about the first thing we think of, you know, and it's not always about replacing doctors. It's about how can robots assist in any way they can of this whole large, complex enterprise of a disaster. So.
You covered all of the bases. That was an amazing insight into the different areas that robotics can help. I'm looking forward to seeing what kind of questions we're coming up with for you, Robin. I know I've got a few myself, but Ross, I'd like to ask you, please, can you introduce yourself?
Sure, yeah. So my name is Ross Mead. I am the founder and CEO of Semio and the vice president of AILA. Just for a quick intro, I'll give a background on Semio, AILA, and then some topics of discussion we can talk about as we go through this. So for starters, Semio is a for-profit company in Los Angeles, defining the way in which people will live, work, and play with robots in their everyday lives. To do that, we're building an operating system and app ecosystem for in-home personal robots. And all of our software relies on natural language user interfaces, such as speech and body language or other social cues. Right now, as it pertains to COVID-19, we are working with a team of content creators from a company called BotCopy to develop conversational content similar to chatbots or voice-based skills that's geared towards informing users about or helping mitigate the spread of COVID-19. We're also developing socially aware navigation systems for mobile robots in natural human environments. So many of the discussions around social distancing or physical distancing have quickly become very relevant. I should also just toss out that social distancing, or what is formally called proxemics, was actually the heart of my dissertation for my PhD. So I can talk about that for way too long. Outside of Semio, I am also the vice president of AILA, Artificial Intelligence Los Angeles. I should mention that we have our founder and president, Todd Terrazas, on the call today. AILA is a California nonprofit focused on engaging the general public in conversations around artificial intelligence and other related or emerging topics. We typically are hosting monthly events around these things, usually 2 events a month. Unfortunately, this month's event was supposed to be on robotics, and Andra was supposed to be flying down to be on that event probably like 2 weeks ago. And obviously that got canceled, and we've since switched over to remote monthly events. And on top of that, to try and help out more with this cause, our current situation, we're supporting independent researchers with their COVID-19 projects by matching teams with skilled volunteers who want to help. So we can talk more about that. Broadly, topics that I would love to talk about today are use cases for social robots and even telepresence robots, as well as social distancing or physical distancing, as you were mentioning, and the impacts of social isolation in these times. And that's it for me right now.
Well, thank you, Ross. And yes, of course, your dissertation was on proxemics, and perhaps you can help us kind of really coin a better term for the distancing that we're having to do now if we're going to be involving robots in what we're doing. But I'd like to ask Wendy Ju to please introduce yourself and say a little bit about what you've been working on, and yes, the book that you wrote on human-robot interaction and emotional response.
Yeah. Hi, everyone. My name is Wendy Ju. I'm an assistant professor at Cornell Tech in New York City. I'm here on Roosevelt Island. Pretty quiet, actually, right now. What I do is I study people's interaction with autonomous systems. So robots are definitely part of that picture. I'm also interested in how people interact with autonomous cars. And so as you know, in that, I actually spent a lot of time looking at how people interact with one another, particularly things like nonverbal cues and things that we do to kind of coordinate and collaborate with one another, and then think about how we can apply our understanding of how interactions happen to machines. I think we think of these things as aesthetic. So my PhD dissertation was on the design of implicit interactions. And I think at the time that I was working on it was, oh, that makes interactions nicer, but it's not critical. Now that we have autonomous cars and we see that like the way that a car signals that it's going to move or not, or the way that people signal that they're going to move or not, if we get these things wrong, it's just be a situation where it's life or death. I think we're starting to understand that a lot of the things that we think of as interaction are only the top layer of what we're actually doing all the time with other people. And if we don't understand those lower layers, it could kill us. So right now, actually, last week I put together a proposal to study how people are interacting with one another in the city around social, when they have social distancing policy. I agree the name is not perfect, but I think it also gets to the heart of what's important to do in this epidemic. I think there's a halo effect around our social interactions because we know they're necessary and good for us. And so people think, well, I shouldn't go to the grocery store, I shouldn't go to the hospital, but surely it can't be bad to go visit my neighbor, or surely it can't be bad to go say hi to my grandmother. And like these kind of our inclinations will kill us, when taken to scale. And so I think when we say social distancing, we're saying like, yes, school is good, but school is bad in this situation. Church is good, but church is bad in this situation. Like really getting at the thing that we are so tempted to do and saying like that is literally the thing that we're trying to stop right now. Like I think that's why they call it social distancing. And it does definitely have a physical corollary. I'm interested to see like afterwards when we see that some people were playing basketball and other people were playing soccer, are those places where people got more sick or not? We don't actually know all the different mechanisms for transmission for this disease, and I think later on we'll be able to figure it out.
Wow, thank you, Wendy. There's I guess there's a really steep learning curve that we as a society are on at the moment. And you know, I feel like robots are just starting to be deployed in areas where they could be helpful. And perhaps now we'll see how much benefit we could gain from robots. We might see a greater uptick in the use of them. But this is a great opportunity for you, Cory, to say a little bit about what you do and about Catalia Health, because you really are one of the, you know, very, very few people who has managed to get a robot startup, a social robot startup out there.
Yeah, it's definitely a unique position to be in right now, I think. So, great to be here. Glad we made this event work virtually. And just give kind of a quick introduction background to myself. So I've been working at the intersection of healthcare and technology for a little over 2 decades. So a lot of my academic training in AI and psychology and always applying that in healthcare. Seems that there are always robots around me. That's Mebu behind me. I've got actually a few around me here, even at home. Have to continue working as all of us have. And Catalia Health is a company I started about 5.5 years ago to do chronic disease care management. And so the concept of that is, of course, not new. We do that at scale for patients around the country and around the world. It's just that the usual model is very human powered. You know, we do this in clinical settings, in the doctor's office, in the hospital. We send people out to homes. We do a lot of work calling patients on the phone to check in on them. We replace all of those by putting actually a physical robot in the patient's home to talk to them. So what we're doing is really mostly on the AI side of generating conversations for patients on the fly for whatever condition they're dealing with. And we build these around specific conditions and have rolled them out in a few. The robotic piece of it is really driven by the psychology around why we would rather be all in a room together, as Robin said earlier, as opposed to, you know, gathering around our computers and staring into the screen at Zoom. And the reason for that is, you know, we get intuitively that that's different. That's why we'd like to be there. But psychologically, we know a lot about what those differences are. So we're face to face with someone, we're more engaged, we create stronger relationships and a number of other things. And earlier research showed that those differences actually carry over into the role. When you put a cute little robot in front of someone that can look them in the eyes while it's talking to them, we actually get a lot of those effects of face-to-face interaction. So it's not just that, you know, things are different and we're having to adjust to working from home. There's actually some psychological differences in how we relate to people around us. And so we've leveraged that to build chronic disease care management programs. So over the last couple of years, we've been rolling these out largely in specialty pharmacies. So we work with some of the largest pharma manufacturers in the world. One of them that's public is Pfizer. We've rolled out some programs with them, and we're helping patients across a number of different conditions really, you know, keep track of how they're doing, stay on therapy, and stay out of the hospital using our AI and robotics platform. And I think what we've seen in the last month or two really highlights the need for this kind of technology broadly. And obviously, we have a number of different approaches to how we use robotics, across the panel tonight. For our contribution and the piece that we're working on, it's really how we help to continue to care for patients on an ongoing basis. When we are in our homes or on the go, and now, unfortunately, that's all of us. And so I think that these kinds of programs that we build, the interactive robots that make it much more effective than trying to deliver the same thing through a screen-based interface. We've shown over a number of years now that it's been very effective in doing that. And now the current crisis, the current situation around the world is really highlighting the need for more of this kind of technology.
Well put. I think we're really seeing the need for robots in a whole range of ways. And I'm sure that you're going to be coming up with some really good proposals for ways of using Mebu, and in the future for, I'm assuming that just staying safe coaching from a robot that is not going to be causing any physical danger for someone who's particularly isolated or elderly, and yet providing still some level of social interaction. I could see that being a very, very useful tool. But before I get too carried away with questions, I would like to ask Ken, if you would like to say a little bit about what you're working on at the moment And if you've got any questions as well for the other speakers, I'd love to hear.
Great. Okay, thank you. Oh, this is weird looking here. All right, thank you so much for putting this together, Andra. I really appreciate you doing this, and it's amazing. You have 100 people in here. You have a great list of speakers, and I want to yield the time for them and for the discussion. Robin is a world leader in this idea of disaster preparedness and using robots for rescue, search and rescue. And I think that there's this fundamental issue that I've been thinking a lot about, which is protecting the healthcare workers, especially at the idea where they're now having to provide these tests for huge numbers of people, increasing numbers of people, and they involve right now the swab. That's quite an uncomfortable and invasive process. And is there any way that we might be able to automate that at some point? I don't think that's going to happen anytime soon, but it's an interesting, I think, goal that could we move in that direction. The other is the idea of just being able, intubation is an incredibly apparently difficult process and very risky because there's a lot of droplets, vaporizing that happens. And that's another area where it would be very helpful if that could be teleoperated. And I just want to also note that the state of the art on telemedicine, telesurgery in particular, and these teleprocedures is not ready for the situation we're facing now. We are nowhere near capable of doing that. And so I think this is a really important wake-up call, as I mentioned last week, to start to develop these technologies. And I'm really interested to hear from this larger group about where they see other opportunities for more near-term contributions. Okay, thanks.
Well, thanks, Ken. Those are three great questions. I've written them down. And at this point, speakers, seize on any question that you would like to say something about and, just dive on it. I won't necessarily ask the right person. And also, if you have questions for the other speakers, then please ask them. So Ken raised three different questions, but before going too deep into that, you didn't say anything about the background behind you, which is one of your new projects. Can you just tell us a little bit about what Alpha Garden is, and I'll come back to your questions.
Thanks, Andra. Sure. This is a project that we've been working on for almost a year now, and this is about putting AI into the context of the complexity of nature, in particular polyculture gardening, which is extremely difficult and complex. And I won't go into all the details behind it, but we're trying to build a robot system that could tend a garden. And what you're seeing in the background is a time lapse of what we call Alpha Garden that we've been working on. And the jury is very much out on this. I'm very, in a way, skeptical of whether we're going to be able to succeed, because managing a garden like this is just beyond the capabilities of robots. So I don't want to sound negative, but I also want to emphasize the gap between where we are today and where we want to be.
So that's a really great point. Nature is far more complex than anything that we're able to build. Now, the questions were intubation, swabbing, and the state of the art in telemedicine. Is anybody got some insights into advances that we're making in those areas, or building blocks that we need to solve first before we can improve?
Hey, this is Robin Murphy. I'd like to speak specifically. There has been a recent report of a robot that was built in China that is doing the swabbing, sticking something up somebody's nose. Okay, that's a great human-robot interaction there. I think one of the things that I'd like to get back to with Ken's talk, he's talking about swabbing, intubation, and that we're far from those. And one of the things we learned from working with the doctors during the Ebola outbreak was that often the best things we can do is not to concentrate on how to protect them or replace them, but instead, what is it that we can do to assist them? For instance, if you're going to be in PPE, giving human compassionate care, direct care, things that are very hard for a human to do, that require specialists, don't look at trying to replace that. Instead, that doctor or nurse has to deal while they're all suited up with things like changing an IV bag, which is not particularly direct and compassionate. It's something that's got to be done. Or they have to take out the trash, or change the bed, which is infected and poses a risk to them versus the risk of actually being at risk, which they signed up to do while these persons in taking care. So the doctors were asking us to think about those things. Could we build a different type of IV system that it was autonomously change the bags and they have to do it, to do the trash, to take out the trash, to haul things around, to have a lab cart that would follow the doctor into the room or the nurse into the room, and you just put the person's hand on it and it would take the blood prick and begin to do the lab work. And then the whole unit just would back up to a wall and the lab people could take the trays out, and it never had to be handled by the nurse or anybody in PPE. It was just there. So I would like to encourage us to think about those kind of applications that assist the medical personnel, and not try so much as like, oh, we're going to do things and we're protecting them. There.
Those are great points. In fact, I'm aware of a number of startups that have pivoted or seized the opportunity to try to solve sterilization of supplies of rooms, or sanitization of hands, these peripheral tasks. And I'm hoping perhaps next week we'll get a selection of robot startups that have taken their logistics robot and are putting it to use in some of these roles. I think every role that robots roll out in, if you pardon the phrase, requires a lot of customization for it to work well. So we don't have anything like a general purpose platform. In fact, Wendy, can I ask you this question next? If we're having to customize robots for each task that we do, how important is it that we customize the interaction and we make sure, for example, and let's use the example of a robot nose swabbing, even if that's perhaps not the most useful kind of thing. Mm-hmm. How would we go about creating an interaction that worked?
That is such an interesting question. I'm not sure about robot nose swabbing, I have to say. I mean, I think a lot of what I do is I spend time looking at how people interact. And, you know, what Robin pointed out is that a lot of the things the doctors are doing are not pertinent to what we think of as the like core task, like maybe getting the sample, but a lot of it might be making people feel comfortable or understand the context of what's happening. So there might be a lot of setup or, you know, like post, you know, action that actually makes the thing that they have to do okay. And those are things that are hard for a robot to do. One of the things that we do when we're doing the interaction design around human-robot interaction is we look at the whole interaction and try not to dismiss all these other things that are happening as irrelevant, but try to understand like what is the, you know, why does someone hold someone's hand? When do they make eye contact? How is the doctor's body oriented? And then really try to break down of those things, like what can be replaced and what has to happen again some other way. You know, I think sometimes the literal mechanical replication of human tasks is actually not the solution. If I think about the way that we take temperature now, for example, it's just like very different than the way it used to be, where you would, you know, try to get someone to hold something in some part of their body where there's a lot of blood rushing by. And now it's mostly done with like lasers or thermal cameras. Sometimes you want to keep the core parts of the interaction the same, but mechanically it can be really, really different.
Okay, that's a really good point. There's an opportunity here for us to reimagine the process. And I think with the example that Robin made about the automatically changing IV bag, then sometimes the answer is an automation rather than a robot. But then sometimes we don't even call a robot if it performs its tasks seamlessly. And just kind of back to you there, I think it takes a lot of work for us to find that a robot is behaving seamlessly. Is that your experience?
Yeah, I mean, I think a lot of things that I would think of as robots, we could have some debates around. I mean, I think the vacuum robot is an example. A lot of people don't really think that's really a robot. There's a lot of these delivery robots that are going around, you know, like delivering food in different trials. And if they don't put eyes on it, people are like not sure that that's really a robot and not just a you know, automated, you know, cooler. And I think this is just like dicing words, not really important. I think that the reason why people want to think of robots as humanoid is because that's what they've been taught by sci-fi to think, but I'm actually a lot more optimistic about robots that have been custom built for different applications. And those things will look a lot like common things that we're used to seeing in the environment with some robotic capabilities. So it might literally be a garbage can, look like a garbage can, but that might have arms so that it can actually put things in a way that is sanitary and doesn't, you know, involve getting doctors and nurses like dirty.
That's an excellent point about the delivery robots. Many of those robots are actually teleoperated, and we don't think about that because they are such discrete units, and so I think we assume that they're powering themselves, and yet there can be a person because they don't have much of a humanoid attitude to them or aspect at all, and yet many of them are being directly controlled by somebody somewhere else in the city or even somewhere else in the world. Does that make the interaction qualitatively different if there's a human behind the controls and we don't know it?
That's an interesting question. I mean, I think that we have seen people do in small controlled experiments, so who knows how it generalizes. We've seen people interact with systems that they think are autonomous, and people interacting with systems that they know has a person on the back end the same way. Kind of like I've seen these pictures of children interacting with Muppets, and they can literally see the puppeteer underneath, you know, the puppet, but they're talking and making eye contact with the puppet because, you know, the seeming interaction is really easy to believe, and so they go with it. And I think that people do the same with teleoperated robots, that if it looks like an autonomous being, they treat it as an autonomous being, and what they cognitively know is really going on doesn't really matter.
Great. Ross, Cory, do you have anything to contribute to that?
I mean, basically, I agree with Wendy. I think it's a very deep topic that we could go into. I think trying to maybe go on to the next topic and more as it pertains to COVID-19 right now. If we can.
Okay, so we'll save some of the deep human-robot interaction questions for, actually we are doing a human-robot interaction online session this week. We're doing industry talks on Friday, and I believe the general chairs are doing an opening tomorrow. And we might be having a human-robot interaction bots and beer because we're doing our virtual bots and beer tomorrow evening as well. We're doing everything virtually, and I know in the questions someone was saying that their eyes are hurting from all of the online meetings that they're doing. So I think we have not yet made virtual as seamless as it could be from the perspective of a personal experience. And in fact, I'm not certain that we're anywhere near having interaction devices that are facilitating our interactions with technology at being as seamless as we'd really like. I think we're going to be conscious of that layer all the way through. But if anyone wants to chime in on that, please do. I was just trying to cover while I was reading the
Andra,
questions.
I'm going to jump in and argue with you on that. So,
okay, good.
You know, a lot of our focus is on making the interaction with technology seamless. So, you know, we ship robots to patients right now across the country, and the setup process for them is take it out of the box and plug it in. That's it. Everything else is just through conversation. You know, many of our patients dealing with chronic disease tend to be older and less tech savvy. We know this from interviewing them, and they're able to use this, and we have to provide virtually zero tech support. So I think there are a lot of ways, you know, depending on the situation, right? If we're talking about a clinical setting where we're sending robots into a hospital or some other clinical setting, that's going to be different. But for what we're doing and interacting with patients in their own homes, we're able to do this in a way that requires, you know, no training, very seamless interaction, and not even really thinking about the technology.
Well, now, harking back to some of the questions here, you did a lot of trialing with medical professionals as well as with your clients, the patients themselves as well. You had to make this work for the patients and for medical professionals as well. And how important was it to really get inside the medical perspective for this?
Well, so, you know, a little bit about our business, you know, at a very high level, our customers are actually the pharma companies because they're the ones paying for these care management programs today. The existing programs are pharmacies have call centers that call patients typically about once a month. So understanding the needs of everyone involved there, whether it's the drug companies who are supporting particular drug brands, or the pharmacies who are supporting the patients directly, or the doctors who are prescribing this, you know, unless we worked closely with them, we would never be able to get this out to a patient. But ultimately, it's the patient who is getting this, and that we're working, you know, in some senses very directly with through our technology and through our platform. So, you know, for better or for worse, it's really about being able to work across all of these. You know, the last 3 years of my PhD, while my PhD was in AI and psychology, I spent my mornings in a clinical setting, actually, you know, in an endocrinology clinic seeing patients. And so that kind of hands-on experience working with the doctors, the nurses, the other clinicians, and the patients at the same time is one of the things that really enables everything that we do. And, you know, we do build robots and AI, yet just under 50% of our team at Catalia Health has a technology background. You know, we have a lot of clinicians, we have a lot of people on the legal and regulatory side. So it's not just any one of these pieces, it's really about how you put them all together to make something like this work.
Great. I think that starts to answer a couple of the questions that we have in the chat. Luke, you wanted to know what MDs really wanted robots for. And I think it would be great if I set up a panel at some point that has MDs to answer that question, because Cory's just pointed out how essential it is to really go to the front line and find out what the problems are. Someone was asking about telling their government what robots were going to be needed for COVID. And I think that the slides that Robin put up with the 5 different areas in which robots are useful in a disaster situation, and that really broke it down. It's not 1 or 2 sorts of robots that are useful. It's a lot of different robots in different situations. There's another question here that's very much about the ethical decisions, and you know, perhaps that's something, Cory, you can speak to. Would a robot or an AI ever be in the position of making the moral or ethical decisions as to who should get a ventilator? How would we navigate that scenario with AI in the medical profession?
Yeah, I saw that question a few minutes ago. I mean, I think that's obviously a very challenging question. I think we're a long way from using robots or AI from doing something like that. And, you know, part of the challenge is when we have people making those decisions, an enormous amount of debate around the ethics of it, as it should be. These should not be simple decisions. I think if you look at, you know, what we're doing, what a lot of other people are doing in robotics right now, it's very much in a supporting role. You know, for example, at Catalia Health, we always come into play once we have a patient with a diagnosis and a prescribed treatment, and we're helping them from there. If we look at, you know, some of the other robotics companies that have been mentioned in the chat here, it's similar in that they're not in a decision-making role. And I think in general, we are a very long way from that. Even if you're looking at, you know, what the FDA refers to as decision support tools, support is a key word there, right? You're helping to provide some guidance, some data, some information, some analysis to a trained clinician to be able to actually make the decision. And I think that's the right place for using this kind of technology right now.
Okay, excellent points. Robin and Ken, I'm going to ask if you can perhaps dive in on one of these other somewhat tricky questions, asking about, would robots be sanitary in assistance? And I think some of the things that occur to me around that question are that robots would be capable of being exposed to UV treatments that people can't. And that is one of the frontline areas that we're seeing disinfecting robots go around and disinfect rooms. And yet this has come up many times in different ways with the, can we make face shields, or can we make masks or other PPE, or for in the COVID crisis, because not all materials are medical grade. And there's a clear understanding of, I think, what is medical grade. But, and this is really why I'm looking to you for this question, Robin. In a disaster, is there a middle ground where you can say, okay, these are good enough in a disaster? They might not have full FDA approval for medical scenarios, but they can 99% sterile, better than what the current situation is.
Well, I think that's one of the important things that we see in every disaster, is that everybody comes up with really interesting, innovative solutions, most of which we have to just say no to, because you don't, in disaster response and in public health, it is considered unethical to experiment. There are, because you can always make things worse. You don't want to make a worse thing. And there is the ethical component of, you've got a robot and it's going to work great, and then it fails and makes things worse, or it distracts the workers, or it takes up, like Ebola, takes up what generators you've got for power. It takes up resources. So these unintended consequences. And so in particular, the medical and public health profession has really set a bunch of standards of when you can relax standards, and who can say, yeah, we can relax it, and who is accountable if something goes wrong. All of these things are very important. And they've already worked through a lot of those. I think it's going back to Jessica's talking about, Captain America, everybody wants to be a hero. It's being respectful of these. And sometimes I think roboticists, we all, in our eagerness to see the solution, and we want to move the field forward, and we want to help, that we forget that these people are experts. They have spent their life thinking about these problems. And if they're saying, no, there's a reason. We don't want to go beyond. We don't want to interfere with that. And so that's also getting back to, I think, some of the great points from Cory and Wendy. It's human-centered design. We got to work with the end users. We've got to understand and walk a mile in their shoes. A lot of the robots that you're seeing being used in clinical applications were already in place for hospital-acquired infections and are now just being accelerated. The unmanned aerial systems that are being used for spraying disinfectants, nobody has any clue that I can tell of whether it's really effective in terms of the normal standards of coverage and disinfectant. And worse yet, we don't see any evidence of what it's doing to the environment. And yet we're seeing that, and here in the United States, it's like, no, we can fly and do that too. And it's like, guys, there's a reason why the FAA is saying, no, let's think about this, because we don't have a good basis to make mistakes. In China, it looks like we're getting some animal die-off from the runoff and things. So anyway, that's some thoughts.
I'm looking forward to having a session on sustainability of robotics and technology generally as a complete side issue to this one. I'd just like to, I've scrolled through the questions, and I suppose if you had to select one sort of robot that's been tested enough to use, what is the robot we should be funding first and fastest? Is it possible to even make a call like that?
A 3D
To
printer.
do what?
Okay, who said a 3D printer?
Ross.
Ross. Wow, I think maybe Jessica might have a comment about that, because most 3D printing designs are non-medical grade and are not acceptable because the filaments are so porous. It's really a kind of health risk. Whereas laser cutters are proving to be very useful in creating face shields. But
Edit, a medical grade and acceptable 3D printer.
I mean, there's various ranges of 3D printers, right? There are, yeah, your average FDM printer, we actually right now don't recommend. A lot of people are trying to print hard cases for N95 masks, and they have had the issues with sealing around the face and things like that. You know, Stratasys makes some really nice printers that have much higher resolution. And as well, there's, if you have an SLA printer, which instead of basically a hot glue gun that goes around on stepper motors and extrudes plastic, it uses UV light to cure resin. They actually have some more elastomers and, you know, down to like microns of resolution. So you can get something like that where it's airtight and seals properly. But the expense is a lot higher to print with resin. So at that point, it's like, how much money are you saving, really? But I mean, you know, in a pinch.
I think we are getting closer to that dream point where each hospital will have a fab lab facility within the doors, so that materials can be printed, whether it's ventilator valves or something else. I have one question here that I really, I think we might just have time to cover. Josh's question about in the manufacturing industry, we're already expecting a spike of orders for robots post-COVID, because the need to have redundancy in the manufacturing chain becomes clear, and that's something that robots can do when people are not able to work in critical roles. Are we expecting the same sort of thing in the healthcare industry? I would like to point out that healthcare is actually the early adopter for robots. After the first automobile welding robots, Joe Engelberger with Unimate and Unimation Company, he moved on and he created the Transitions Robot Corps with a helpful robot for hospital use. And that was a logistics robot delivering meals or bedding or linen. And that was really the next area of commercialization for robotics. And we've seen quite a lot of logistics robots in hospitals. What we're not seeing yet is we've just hit the start of the flexible navigation, flexibly navigating robots. We hope that we're going to have a lot of better manipulation abilities in robots moving forward. But right now, we now have robots that can navigate, that can change their course and be responsive. And they're safer to operate around people. So we can come up with a lot more logistics tasks that are taking samples from one part of a hospital to another part, or making changeable delivery decisions. So you don't have to have one fixed route like a train line. It's like now we have robots that are operating more like taxis, not cargo trains. But that was my 2 cents there. I would like to ask everybody who's been speaking, if you want to finish the discussion with, we started on that topic of what is the one robot you really want to see? Let's just finish that off and go around everybody else. What is the one robot you really want to see? Ross, you have put your 2 cents in with the 3D printer. Who wants to go
with something
next?
better? It's
I have, actually, I'll just say one, which is, I do think that this end of life situation we're hearing about, where people are alone in the hospital beds or on ventilators and they're dying and they cannot be with family or anybody else, is a horrible human tragedy. And I think that if there's some way, and I just think about this now, but is it a possible, sorry, everybody's howling out here at 8 p.m. every night. Is it possible to have a robot that in some way would allow some telepresence engagement with family members. I know it's not ideal, but I just want to put it out there.
That would be wonderful. We'll have to take that to Travu from Omni Labs, because they're looking at having an arm on their telepresence robots, and they're doing a lot of hospital work. And I saw a lot of great robotics companies mentioned as well. Perhaps next week we'll focus on robot startups in this space again. Any more suggestions for...
Andra, real quick, just to amend my joking recommendation, to follow up on actually what Ken said, I really think that telepresence and social robots that could assist in more of these isolation scenarios, be it end-of-life care or in-home for people who are not with families, or especially for older adults who are separated from their families, but hopefully safe wherever they are, is some way to increase that social connectedness to try and mitigate things like social isolation and depression in these populations is something that's absolutely crucial. Even beyond the medical impacts that we're seeing right now, we might see psychological impacts in the long term. And so it's something that a lot of the social robot companies that went down in the past few years, this is unfortunately an opportunity that they were not, it wasn't quite around, fortunately, back then, that where they could have been beneficial now.
Yes, it is really feeling like some of those companies were just a little bit too early, and we wish they were here now. Are there any final words from...
Well, I think one of the challenges with asking for, the right robot or the ultimate robot is not really thinking about, the range. And I think we did a great job of kicking this off with Robin, and, that slide that you presented, Robin, showing many different applications of this kind of technology. And I think the right way to think about it is truly as an enabling technology that we can leverage in so many different applications, so many different areas. There are a lot of places that we can use robots, AI, other technologies right now to help focus on solutions to these kinds of problems.
Thank you very much, Cory. And
I'll jump in. I mean, I think, Wendy, I think this week, maybe last week I was feeling this too. I think that the need for kind of like basically a personal fetch robot becomes something that's been more obvious. I think we've seen a lot of these delivery robots in their ways deployed as fleet, to deliver things from stores. But I mean, I think the degree to which we find we have many, many small little errands to run, I think we can actually see that there are little things that could be done all the time around the house, that if you had this around, it would be great. And then in a real true emergency, then you would actually have something like that under your control.
That's an excellent suggestion. And I think a final word to you, Robin, and particularly, is there anything that we can do to help the field of disaster robotics?
Well, that's an easy answer. I mean, the things you're doing are exactly the right things. Thinking about this, trying to bring the community together, because as Cory's pointing out, it's not just one thing. There's so many varieties. And one of the things about robotics is mass customization. But the challenge I would set to you, the biggest gap that I'm seeing right now in robotics that are being deployed and being talked about deployed, is we don't have good arms. So having telepresence, but being unable to pick up things, that interferes with telenursing, that interferes with social robotics of pulling the covers up on grandma. It also interferes with being able to keep the electricity and the water flowing and turning valves and the trains moving. And so I think those are some of the things that we need to be looking at in the future. We've done such a great job of getting robots that can move around, the navigation, as you pointed out. UVD is one of the decontamination robots that uses SLAM to get around the hospital. All these things are there, but now we've been good at moving and at seeing at a distance. Now we got to get good at manipulating at a distance. And I think this is exactly the group of smart people to be working on it.
Well, thank you for those closing words, Robin. That was, your contribution has been fantastic. And I thank all of the fabulous speakers for being here this evening. And I would like to particularly thank behind the scenes Bo Amber from Kickstarter and Erin Pan from Silicon Valley Robotics for helping behind the scenes. Ross, we didn't wake your puppy up. So
She
yay.
just made her first little yelp just as we were finishing up. We got it.
I know, and when the howling was in the background, it was not actually you. Now, there will be some more human-robot interaction webinars coming this week as part of the 15th Annual International Human-Robot Interaction Conference going online. Plus, we have some other events like Bots and Beer online and a Women in Robotics Icebreaker. Both of those are tomorrow.